Assalamu alaikum, my dear students. In this class, I am going to discuss about the Fleming's left-hand rule. Left-hand rule. Okay. When should we use this Fleming's left-hand rule? Okay. The clue is when there is a wire, it's called a conductor, a copper wire, and which is placed in between the magnets. Now, what will happen? The magnet produces a magnetic field lines and the current carrying conductor has magnetic field lines around the conductor. So now these two magnetic field lines interact each other. A force is acted onto the wire because of this interaction, magnetic field lines interaction. So what will happen? This wire will move. This wire, movement of wire, this direction we have to find using the Fleming's left hand rule. So when will we use? When there is a with current, wire with current and a magnet. When these two informations are there, then if you want to find the in which direction the force is acting onto the wire and in which direction it will move, the motion, the direction of motion of the wire, that's all. This is our target, in which direction the force is acting onto the wire. This is our target, so the same direction it will move. Which will move? The black wire. Just an example here, a black line, the line, it will move. So what are the possible directions we have? The possible directions of the wire, right? So now in this case you can see here the wire can move to the left of the page, the wire can move to the right of the page. You can change the color, may move to the left, this is the right side, sorry, right side of the page, or it may move to the left side of the page, or the wire can move top of the page, top, or the wire can move to the bottom of the page, or the wire can move into the page, or the wire can move out of the page. So there are six directions we have. The force can act on to the wire. So in these six directions can be found using Fleming's left hand rule. Okay, so how can we find out that? Now I can draw one by one. So okay, now here is a north pole and here is the south pole. Now here is a wire, the current is out of the page. It is mentioned in the question, the current flows through the wire out of the page, out of the page, it is mentioned now, out of the page. So what we have to do, we have to see that it is a Fleming's left hand rule or not. It is a Fleming's left hand rule. How? What are the clues? I told you magnets, north and south pole magnet is here, and a wire with current. Now Fleming's left hand rule is applicable. You can use it, Fleming's left hand rule. For what? To find out the direction of force acting onto the wire. So which direction the wire will move? Either right side, left side, top, bottom, into the page or out of the page. Six directions it can move. First, the alignment of the fingers. Just we are going to use three fingers. What are they? What are they? Now I can expand this. Here you can see, here this finger is called index finger, index. And you can see this finger is known as middle finger, middle. And this thumb, thumb finger. Now you are going to align these three fingers. Now I have some mnemonic you can by heart. This thumb is F, here index M, and this middle C. What it means? F denotes force, the direction of force acting onto the wire. M denotes magnetic field, the direction of magnetic field. And the C denotes current, the direction of current. In this case, the direction of current is out of the page, out of the page. You can see here, three dimension, you just imagine the current is, the finger is out of the page. Okay, now you can, and this is, these three fingers we are using, only these three fingers. So FMC, father, mother, children. FMC, you can by heart father, mother, children. The father is a force, M is a magnetic field, and C is the direction of current. Okay, now listen carefully. Now we have the alignment with one question, we can do it. Okay, so here is a magnet south, and here is a magnet north pole. That means actually it is a horseshoe magnet, like this. So we simplified the diagram. Okay, north and south. Now here is a wire, a three dimension you have to imagine. Now the current is out of the page. If they give like this, out of the page, direction of current is out of the page, out of the page, the direction of current I. So my middle finger is F M C. C is the current, direction of current is out of the page, it is aligned now. And then always the index finger always pointing the south. Now if these two fingers are aligned exactly with the question paper, then you can say the force is acting onto the wire upwards, because my thumb finger is pointing up. So the wire is going to move to the top. So I have to say top of the page, top of the page. Is that clear? Okay, in case if the magnetic field lines are changed, here is the south and here is north. So it is very difficult for your what do we say, your finger, the hand movement to other side is very difficult, you can't move it, it is difficult. So instead you change your finger, direction of finger. Better you can turn the page, the question paper. You change the question paper direction, just you turn, flip the question paper so that it will be here north, so it will become here south. Just rotate the paper, don't rotate your hand. And now what will happen now, this one index is pointing south. This is very important, always your index finger should point to south. Okay, now you can flip your if you want, you can flip your uh, the upside down, you can make it like this. If in case if they mention the direction of current is into the page, if the direction of current is into the page, what you can do, you can align your finger like this after rotating the paper. Now it is mentioned in the question, direction of current is into the page, into the page, direction of current into the page. So now my current is here, middle finger is current, F M C, direction of current is middle finger and it is going into the page, and I am aligning my middle, the index finger to the south automatically. Now this wire will move to the bottom of the page. Why? Because my thumb finger points to the bottom, so the force acting onto the wire is bottom of the page. So you can write bottom of the page. If it moves on the top, you can say top of the page. It depends the alignment of your fingers. So always don't forget to align your index finger first. Okay, what I said, index finger always to the south, and align your direction of current. If it is into the page, current, okay, into the page in this position. If it is out of the page, in this direction. See, here is a south, because my index finger always points south, and now the current is out of the page. Here my current is into the page, so the force act on the wire is on the top, force acting onto the wire is bottom. That's all. Now the wire will move on the top, here the wire will move the bottom. It is because you change the direction of current. Here the direction of current is out, here the direction of current is into the page. Because of direction of current, the force acting on the wire is reversed. One is on the top, another is at the bottom. What if magnetic field direction and the current direction is changed together? No change. It will not be a change. There won't be any change. Example.